No time to intervene. It wouldn't feel like the end of the world at first. At first, it would sound like trivia. A headline mentions an asteroid. Social media argues whether it's real. Someone posts a dinosaur meme. Most people keep scrolling. But then the numbers start appearing. 66 million years ago, an asteroid about 10 kilometers wide hit Earth near what's now Mexico. It released energy equivalent to 10 billion Hiroshima bombs and wiped out 75% of all species, including the dinosaurs. Here's what movies don't explain. You don't need a dinosaur killer to end your life. An asteroid just 100 meters wide, roughly the size of a football stadium, can flatten an entire city. A 300-meter asteroid can devastate a region the size of a small country. Objects this size pass uncomfortably close more often than you think. In 2013, a 20-meter asteroid exploded over Chelyabinsk, Russia. It shattered windows across 6 cities and injured over 1,500 people. No one saw it coming. It approached from the sun's direction, detected only after it detonated in our atmosphere. Asteroids move fast, between 20 and 70 kilometers per second, fast enough to cross the entire United States in under 2 minutes. At those speeds, a trajectory shift smaller than the width of a human hair over millions of kilometers means the difference between a direct hit and a clean miss. This is where the Hollywood plan falls apart. Even if you detect a large asteroid today and launch nuclear missiles tomorrow, detonating it doesn't vaporize the threat. It fragments one deadly object into dozens of deadly objects, all still heading toward Earth on the same trajectory. Real deflection missions require years of advanced warning and precise gravitational nudges, not last-minute explosions. Now imagine scientists confirm it. Impact in 24 hours. Governments issue statements but don't declare martial law. Flights continue. There's no evacuation plan that makes sense because the uncertainty zone spans hundreds of kilometers. No city knows for certain if it's in the path. So how do you die? Not because no one tried, not because technology failed. You die because space operates on physics, not on human timelines. By the time everyone agrees on what's coming, the asteroid is already doing exactly what momentum decided millions of years ago. Inside the impact zone. If you're inside the impact zone, there is no final moment of realization. Asteroids strike at 20 to 70 kilometers per second. By the time light from the impact reaches your eyes, the physics has already finished. Start with a 300-meter asteroid hitting a major city, let's say New York. The crater would span 3 to 5 kilometers, but the true destruction zone extends far beyond that. Manhattan wouldn't collapse. It would be erased. Concrete, steel, glass, materials we think of as solid, behave like liquid under pressures millions of times higher than atmospheric levels. Buildings don't crumble. They cease to exist as recognizable structures. The energy release? Roughly 1,000 megatons, about 70 times the largest nuclear weapon ever tested. Now scale it up. A 1-kilometer asteroid releases energy comparable to 500,000 Hiroshima bombs. That's enough to obliterate an area the size of Belgium or Switzerland in seconds. If it struck Western Europe, entire nations would vanish while neighboring countries experience total infrastructure collapse. Then there's the extinction level threshold. An asteroid becomes extinction level at around 10 kilometers wide, the size that killed the dinosaurs. When it struck, it carved the Chicxulub crater, 180 kilometers across and 20 kilometers deep. To visualize the scale, if you place this asteroid over Manhattan, it would extend beyond the visible horizon in every direction. Inside an extinction-level impact zone, continents aren't destroyed, they're rewritten. Shockwaves propagate through Earth's crust like global earthquakes. The ground rebounds upward. The atmosphere ignites. Rock vaporizes into plasma hotter than the surface of the sun. Nothing survives. At this scale, survival isn't about which building you're in or which bunker you reach. It's about whether your hemisphere still exists afterward. Heat and shockwave. The impact zone ends in seconds. The damage does not. When an asteroid strikes, the first thing that escapes the crater isn't debris, it's heat. Thermal radiation travels at the speed of light, reaching areas far beyond where the ground is destroyed. Take that same 300-meter asteroid hitting New York. Manhattan is gone instantly, but thermal radiation doesn't stop at the crater's edge. Within seconds, exposed surfaces ignite across a radius of 250 to 300 kilometers. Fires break out simultaneously in Philadelphia, Boston, and Washington, D.C. Trees, cars, rooftops, anything flammable combusts almost at once. People 200 kilometers away wouldn't see the asteroid. They'd see the sky flash brighter than midday sun, followed immediately by blistering heat. Windows explode outward, turning buildings into blast furnaces as superheated air rushes inside. Then comes the shockwave. This isn't wind. It's a wall of compressed air moving faster than sound, carrying overpressure strong enough to collapse reinforced structures. For a 300-meter impact, building-destroying overpressure extends 400 kilometers from ground zero. Steel frame buildings buckle. Highway overpasses collapse. Power grids fail. All communication ends. Remember the Chelyabinsk asteroid? 20 meters wide, and it shattered windows across 6 cities. That shockwave injured 1,500 people from an airburst 30 kilometers above the surface. Now scale that up 15 times in diameter. The devastation expands exponentially. For an extinction-level asteroid 10 kilometers wide, thermal radiation ignites forests across entire continents. The shockwave travels thousands of kilometers, toppling cities that never even saw the flash. You don't need to be anywhere near the crater. You only need to be within reach of the energy it releases. The asteroid hits one location. Heat and shockwave decide who else dies. Global disruption. By this point, the asteroid itself is no longer the threat. The planet is. Let's say a 1-kilometer asteroid strikes Central Europe, somewhere near Germany or Poland. The impact site is gone. But seismic energy doesn't respect borders. It travels through Earth's crust at several kilometers per second. Within minutes, earthquakes ripple outward across the continent. These aren't minor tremors. Impacts of this magnitude trigger earthquakes in the 8 to 9 range, comparable to the 2011 Tohoku earthquake that devastated Japan and killed over 15,000 people. Fault lines as far away as southern Italy, Scandinavia, and North Africa slip. Buildings collapse in cities never designed for seismic activity. Infrastructure fails across regions thousands of kilometers from impact. Now look west across the Atlantic. Even someone in the United States, 6,000 kilometers away, isn't safe. And if the asteroid hits the ocean instead of land, the danger multiplies. A 300-meter asteroid striking deep water generates tsunamis with initial wave heights exceeding 100 meters near the impact point. These waves race outward at 700 to 800 kilometers per hour, the speed of a commercial jet. As they travel, they lose height but gain reach. By the time they hit the U.S. East Coast hours later, they're still 10 to 30 meters tall, more than enough to obliterate coastal cities with almost no warning time. Then comes the debris. Material ejected into the upper atmosphere begins raining back down across the planet. Some fragments re-enter at hypersonic speeds, reheating the surrounding air and igniting wildfires thousands of kilometers from the impact site. Within hours, skies darken. Dust particles suspended in the stratosphere begin blocking sunlight. Temperatures drop, and agriculture everywhere on Earth begins to fail. At this stage, death isn't localized to one continent. You don't die because the asteroid hit near you. You die because Earth redistributes the impact energy to everywhere life depends on stability. Aftermath collapse. Let's say the asteroid hits North America. The danger doesn't stay there. Within hours, billions of tons of dust and vaporized rock are injected into the upper atmosphere. Within days, this debris cloud encircles the entire planet. For a 1-kilometer asteroid, scientists estimate sunlight drops by 10 to 20% globally. For a 10-kilometer extinction-level impact, sunlight can decrease by 70 to 90% for months, possibly years. That's not just darkness, that's agricultural collapse. Most food crops require at least 50 to 60% of normal sunlight to complete photosynthesis and produce usable yields. Below that threshold, harvests fail. Even on the opposite side of Earth, Asia, Europe, Africa, fields stop producing within one growing season. Here's how fragile the system actually is. In the United States, grocery stores carry roughly 3 days of food inventory. Distribution centers might hold a few weeks. After that, everything depends on new harvests. When those harvests fail globally, there is no backup supply chain. Even if every remaining calorie were perfectly rationed and distributed, which has never happened in human history, global food reserves would sustain the population for months, not years. Electricity accelerates the collapse. Power grids depend on constant fuel deliveries and functioning supply chains. When transportation networks fail, coal and natural gas stop arriving at power plants. Water treatment facilities shut down. Hospitals lose refrigeration for vaccines and medications. Insulin, antibiotics, oxygen supplies, gone within weeks. Then there's temperature. After large impacts, global average temperatures can drop 5 to 10 degrees Celsius. That's a larger shift than the difference between today's climate and the last ice age. Summers vanish. Winters arrive early and persist. Regions that barely froze before now experience killing frosts year-round. At this point, it doesn't matter where you were when the asteroid hit. You don't die because you were close to the impact. You die because sunlight, food, electricity, and clean water all fail simultaneously. And modern civilization has no mechanism to survive that combination. The asteroid's impact lasts seconds. The collapse takes everyone else. Subscribe to see what else is coming and whether we'd see it in time. Comment below. Would you want to know or would you rather not?